In this video, we're going to be graphing a system of inequalities. So you're going to be given two inequalities, and you're going to graph the lines using the slope and the y-intercept. But first, it has to be put into slope-intercept form, meaning y equals mx plus b. But instead of the equal sign, you'll have a greater than, less than, greater than or equal to, or less than or equal to symbol. So the very first thing is you have to identify that slope and y-intercept so that you can graph it. And it does have to be in y equals mx plus b form. If there's anything on the same side as y, move it to the other side. Next step, if you have greater than or less than, you're going to draw a dashed line. So when you're graphing the line, it's actually going to just be dashed. It's not going to be filled in, because if it's strictly greater than or less than your line, it does not include the line itself. That's why it's dashed, meaning the line is not included. However, if you have greater than or equal to or less than or equal to, then you're going to draw a solid line. Because of the or equal to part, it means it does include that line. Okay. So if you have greater than or equal to, you're going to shade above the line. So above the line, if I graphed it like this, I would shade above the line. This would be values that are greater than or equal to the line. And if you have less than or equal to, you're going to shade below the line. So if I had a line drawn, I would end up shading below the line. We'll talk about this a little bit more when you actually have a coordinate grid, so you can kind of see what I'm talking about. All right, so you're always looking for a solution when you're graphing a system of inequalities or equations. So the solution to this system of inequalities is an area that is double shaded. So you're going to be graphing two inequalities. You're going to be having dashed and dot and solid lines, and you're going to be shading above and below. So when you shade for both of your inequalities, the place where the shading overlaps is your solution. So let's go ahead and do one so that you can see what I'm talking about. All right, so this first one, we have y is greater than 2x minus 3. So very first thing, we're going to identify the slope. Remember, because it's in y equals mx plus b form, the slope is a number that's multiplied by x, so in this case 2. But I'm going to make it into a fraction by putting a 1 below it, so it's in rise over run form. And my y-intercept is what's added or subtracted on. So in this case, it's -3. Okay, so I am going to graph this one. So I start with my y-intercept. This line goes to the y-axis at -3. So I'm going to put a dot at -3. The slope is +2 over +1. So I'm going to rise 2, run 1. Because they're both positive, you go to the right for both. Okay, y is greater than this line. Because it's strictly greater than, it's not or equal to, it means that we have to have a dashed line. It does not include the line. So I'm just going to draw a dashed line through my 2 points that I graphed. Okay, so this is kind of a little more confusing. We're going to figure out which side of this line to shade. So it says y is greater than our line, meaning I'm going to look at the y-axis. The y-axis is right here. So my line crosses through the y-axis at -3. I'm going to shade on the side of the y-axis that has y values that are greater than the line. So just looking at the point where it intersects my y-axis, that's all I'm looking at. I know that above it, these values would be greater than -3. The values below it are less than -3 where my inequality, my graph, intersects the y-axis. So I'm going to shade on the side where the y values are greater than the point where my line intersects the y-axis. And I'm just going to very lightly shade in that side, because for this inequality, every single point on this side of the graph is going to be included in the solution for this inequality. The solution that we're looking for ultimately at the end is where the shaded part intersects for the two. So overlaps. So I am actually going to use two different colors so you can kind of see where they overlap. So my first shade is going to be in blue. And then I'm going to do green for my other one. So, all right, first we have to find the slope and the y-intercept. Slope, it's in y equals mx plus b form. Slope is what's multiplied by x. Well, there's a negative multiplied by x, but anytime you have an x, you have at least one x. So it's actually -1. We're going to put it into a fraction by putting a +1 below it. My y-intercept is what's added on, that +2. So now we're going to graph. Okay, so this graph will go through my y-axis at 2. The slope is -1, so down 1, over +1 to the right 1. And its y is less than or equal to. Because it's or equal to, it is a solid line. Right now I'm ignoring that other line that I drew. I'm ignoring the shading. That does not matter. I'm just worried about my green line right now. Okay, now I'm going to figure out where I'm going to shade. Again, I'm going to completely ignore everything that I did for blue. I don't care about it right now. I'm going to shade where the y values are less than or equal to my line. So I look at where my line went through the y-axis. It went through the y-axis at 2. So looking at the y-axis, if I go up, these y values are going to be greater than 2. If I go down, these y values are less than 2. So y is less than or equal to our line. So I'm going to shade on the side that it's less than. That means I'm going to shade everything below, ignoring that blue area shaded and that blue line. All I care about is shading below this green line of mine. You can kind of see, hopefully, where it's double shaded. Okay, so I've shaded in green all down here and in blue all up here. So the area that's double shaded is this whole area over here, meaning this is my solution. So where it's double shaded, I'm just going to shade that in even darker, meaning this is my solution. Any point that falls within this area that's shaded would be part of the solution of my inequality. So even though this part up here and this part down here, they were shaded one time, they're not part of the solution because it has to be where the two inequalities overlap. Okay, the other thing you need to look at is, well, what's bordering our double shaded area? So we have our two lines that border it. So if it's a solid line that's on the border of the double shaded area, points on that line would be part of the solution. But down here, because it's a dashed line, that's not part of the solution. This point would not be part of the solution because if it's dashed, it's strictly either greater than or less than the line. In this case, it's greater than because we're above the line. So over here is all that's my solution, including points on this line. Not down here though, because that's not area that's double shaded. It's not bordering the double shaded. All right, so let's try one more, then I'll let you try two on your own. All right, so this one, we have a slope of 2/3, y-intercept of 1. So it goes through our y-axis at 1. Slope is rise 2, run 3, and both are positive, so up 2 to the right 3. And it's greater than or equal to. Because it's or equal to, it has to be a solid line. And greater than. Well, if I look where my line goes through the y-axis, greater than would be above. So I'm just going to lightly shade in everything above my line. Because if I go to the y-axis below, these numbers are less than the line. So it's always paying attention, y values that are greater in that case. Now, my second one, I have a slope of -1/2. I'm just going to put that negative with the top. So -1 over +2. Remember, when you have a negative out front, it just stays with either the top or the bottom. Don't put it with both. Y-intercept is -2. So that means that we start at -2 on the y-axis. Slope is -1, so down 1, over +2 to the right 2. And this is y is less than, so it's a dashed line. It's strictly less than, not equal to. So we have our dashed line through those 2 points. And just looking at blue right now, we're going to look at where the y values are less than the line. So here's where my line goes to the y-axis, just looking at the y-axis for now. Y values are greater than up here, y values are less than down here. So I'm just going to shade everything below my blue line. Again, I ignore the pink for now until I'm ready to find the solution. So the solution is where it's double shaded. It's double shaded only in this little V area over here. So I'm going to shade that in dark. This is my solution area where it is double shaded. Okay, so I'm going to have you go ahead and try a couple on your own. When you're ready, I will go through the answers with you. All right, so the first one, we have a slope of 1, so put a +1 below it. A y-intercept of -4, so it goes through the y-axis at -4. Slope is rise 1, run 1. And that is a solid line because it's or equal to. Let's see, there we go. And we have y is greater than or equal to, so I'm going to shade everything very lightly above it so I can tell where the shading is going to be. And my other one, we have a slope of 3, put a 1 below it, so it's in rise over run form. A y-intercept of -2, so it goes through the y-axis at -2, and we're going to rise 3, run 1, and then connect those points. Let's see. Y is less than or equal to. Again, this one was or equal to, so it had to be solid line. Less than, so I'm going to look at the y-axis and go to the side where y values are on the y-axis are less than the y-intercept. That means go below. So I'm just going to go below that blue line, ignoring where the pink is for now, and seeing where it's double shaded. So the double shaded area will be in this V right here. So always make the double shaded area darkest so you know that that is where the solution is. All right, and then hopefully you got that last one done. All right, so slope is -1 over +2. Y-intercept is +3. So it goes through the y-axis at 3, and then your slope is down 1 to the right 2. And since it's strictly y is greater than, hopefully you remembered it's a dashed line. You do not connect the little dashes because it's strictly greater than. And I'm going to go to the side of where my line goes to the y-axis and go to numbers that are greater than on the y-axis. Shade that small area in. Then I'm going to go to my second one. Oh, but this one's not solved for y. I have to get y by itself. So I'm going to add 2x to both sides of that inequality sign. So I get y is less than 2x plus 5. So you had to solve for y. Slope is positive 2. I'm going to put a 1 below it so it's in rise over run form. The y-intercept is positive 5. So it goes through the y-axis at 5. Slope, well, I can't rise 2 to the right, rise up 2 and then right 1. So I'm going to go down 2, left 1. That's the exact same thing as up 2 to the right 1. And its y is less than, so it's going to be a dashed line also. Going to look at where we would have less than, y values that are less than. The point where our line goes to the y-axis would be down below. So I'm going to shade everything down below that pink line. Again, ignoring blue until I'm ready to figure out where it's double shaded, which is up in the corner. Hopefully you were able to identify that area. If not, go ahead and go back and double check any mistakes that you made. And also double check that you did do dashed lines for both of those. And this is Solving Systems of Inequalities.